How the solar system works. A detailed explanation. The solar system is a vast and complex system of celestial objects held together by gravity, with the sun at its center. It includes planets, moons, asteroids, comets, and various forms of cosmic dust and gas. Understanding how it works requires a dive into the principles of physics, especially gravity, orbital motion, and thermodynamics. 1. The Sun, the central powerhouse. The Sun is the largest object in the solar system, making up about 99.86% of its total mass. It is a massive glowing ball of hot plasma, primarily composed of hydrogen, about 74%, and helium, about 24%. Through nuclear fusion, the Sun converts hydrogen into helium in its core, releasing an enormous amount of energy. This energy travels through space as light and heat, powering weather, climate, and life on Earth. The Sun's gravitational pull keeps all the other objects in the solar system bound in orbit around it. 2. Planetary orbits and gravity. Gravity is the fundamental force that holds the solar system together. Every object with mass exerts gravitational force, but the Sun, being the most massive, dominates. Planets orbit the Sun due to a balance between two forces, gravity pulling them inward, inertia, or their forward motion, pulling them outward. This creates an elliptical path around the Sun, as described by Kepler's first law. The closer a planet is to the Sun, the faster it travels due to stronger gravitational attraction, Kepler's second law. 3. The planets, inner versus outer. The planets in our solar system are divided into two categories: terrestrial, rocky planets, Mercury, Venus, Earth, Mars; smaller, solid, closer to the Sun, have few or no moons and no rings, gas and ice giants, Jupiter, Saturn, gas giants, Uranus, Neptune, ice giants, massive, mostly made of hydrogen, helium, water, methane, and ammonia, have many moons and complex ring systems. Each planet's distance from the Sun affects its temperature, composition, and atmospheric conditions. 4. Moons, asteroids, and other bodies. Moons. Natural satellites that orbit planets. Earth has one, while Jupiter has over 90. Moons vary in size, composition, and origin. Asteroid belt located between Mars and Jupiter contains thousands of rocky bodies, remnants from the early solar system that never formed into a planet due to Jupiter's gravity. Comets made of ice, dust, and rocky material come from the Kuiper belt and possibly the Oort cloud, develop glowing tails when they approach the Sun due to solar heating. 5. The Kuiper belt and Oort cloud. Beyond Neptune lies the Kuiper belt, a region full of icy bodies and dwarf planets like Pluto. Even farther out, though still theoretical, is the Oort cloud, a spherical shell of icy objects believed to be the source of long-period comets. 6. Solar wind and the heliosphere. The solar wind is a constant stream of charged particles released from the Sun. It travels throughout the solar system and affects planetary atmospheres and magnetospheres. The solar wind forms a protective bubble around the solar system called the heliosphere, which shields it from interstellar radiation. Planets with strong magnetic fields, like Earth and Jupiter, can deflect this wind, protecting their atmospheres. 7. The formation of the solar system, about 6 billion years ago. The solar system formed from a cloud of gas and dust called the solar nebula. The nebula collapsed under its own gravity, forming a spinning disk. The center became hot and dense, forming the Sun. The remaining material clumped into planetesimals, then protoplanets, and finally full-sized planets. The inner solar system formed rocky planets due to high temperatures, while outer regions allowed for the formation of gas and ice giants. 8. Why the solar system is stable. The solar system maintains its structure because of gravitational balance and orbital resonance. Planetary orbits don't cross because of stable distances and speeds. Some moons and planets are in orbital resonances that keep their movements synchronized. Despite this, minor changes do occur over millions of years, known as orbital perturbations. Conclusion. The solar system is a beautiful example of natural order governed by physical laws, from the powerful fusion engine of the Sun to the frozen edges of the Kuiper belt. Every object moves in harmony due to the interplay of gravity, motion, and time. Studying this system not only helps us understand Earth's place in the universe, but also provides clues about how other star systems form and evolve.